Hello again folks, today we're going to talk about the Lambert W function, and in particular how to integrate it. Well, the Lambert W function is defined as being the inverse function of the function x e to the x. That means it is defined implicitly as x being equal to y e to the y. Well, of course we have a domain and range, and that's what we'll explore now. The green curve represents the relation x equals y e to the y. And to get a function of x, we must limit our range to y starting from -1 up to positive infinity. So the red line here represents y equals -1, and our range is y is in the interval -1 up to infinity. Our domain, which is x, starts from x is equal to negative e to the -1 up to infinity. Now that we got our domain and range, let's start integrating the function. Well, it's not obvious how to start integrating a function that's only defined implicitly. So the first step at actually integrating the function is differentiating it. Now we got our implicit relation, x is equal to y e to the y. We differentiate both sides with respect to x. The derivative of x with respect to x is 1, and that is going to be equal to the derivative of y with respect to x times y e to the y plus e to the y by the product rule. Now we can multiply both sides by dx to find out that dx is equal to dy times y e to the y plus e to the y. Factoring out e to the y, we get that dx is equal to dy times y plus 1 e to the y. Keep that on your mind, we are going to use it later. Now, dy dx is equal to 1 over y e to the y plus e to the y. And knowing that y e to the y is equal to x, we replace it by x, and we replace e to the y by x over y. Now we got that the derivative of the Lambert W function with respect to x is equal to 1 over x plus x over y. Now we factor out an x in the denominator and multiply everything by y. We get that the derivative of the Lambert W function with respect to x is equal to y over x times y plus 1. And since y is the Lambert W function, we get that the derivative of the Lambert W function with respect to x is the Lambert W function over x times the Lambert W function plus 1. Now we can actually start integrating the Lambert W function. By integrating it by parts, we find out that the integral of the Lambert W function with respect to x is equal to x times the Lambert W function minus the integral of x times the derivative of the Lambert W function. Well, that will be x times the Lambert W function minus the integral of x, and then we replace the derivative with what it actually is, what we calculated back 1 minute ago, which is x w of x over x times w of x plus 1. This comes down to x w of x minus the integral of, we're going to replace every w of x we see by y, and every x we see by y e to the y. So this becomes y squared times e to the y over y e to the y times y plus 1. Now don't get angry yet, we're gonna simplify everything in a bit. I just wanna do something first. Now remember when I told you to keep in your mind that dx is equal to dy times y plus 1 e to the y? Now we gotta replace that dx in the integral with that new expression. So you get that the integral of the Lambert W function with respect to x is equal to x w of x minus the integral of y squared e to the y over y e to the y plus 1 times e to the y plus 1 dy. Now there's a lot of simplification, and what's left is that the integral of the Lambert W function with respect to x is equal to x times the Lambert W function minus the integral of y e to the y dy. Well, that's easy to calculate. Using integration by parts, we find out that that integral on the right is equal to y e to the y minus e to the y plus c. And now when we replace y e to the y with x and replace e to the y by x over w of x, you can see here y. it all comes down to the integral of the Lambert W function with respect to x is x times the Lambert W function minus x plus x over the Lambert W functions plus the integration constant c. That's all for today, folks. We've integrated the Lambert W function, we've differentiated, we've learned what it was. Now, next video is gonna be about calculating volumes and surface area of higher dimensional spheres in 4 dimensions, 5 dimensions, and so on. So if you don't want to miss that, make sure you're subscribed. If you liked the video, don't forget to press like, to subscribe, and share it with your friends. And until next time, go Physimathize the world.